Hi, today we're going to be looking at an Aurora Power 1 solar power box. I think it's a solar panel inverter. A friend of mine basically phoned us up and told us that it blew up and he was getting a new one fitted, and I says, "Oh, what are you doing with the old one?" And he says, "Well," he says, "I'm just going to bin it." I says, "Oh, don't bin it." I says, "I'll have it." I says, "We'll see if we can fix it and maybe do a repair video on." So what we'll do, we'll take the front of it off, I'll rig some power up to it and we'll see what it does. Now, he did say that the unit is completely dead, it doesn't light up, it doesn't do anything. So it'll actually be quite interesting to have a look and see what's inside of it. Right, I'm going to start by removing this front cover. It's a Torx T20. Right. So we have some DC inputs here, which I assume must be for the solar panel. So we've got in 1, which is at the left hand side there, and in 2 at the right hand side. And then we've got grid, which must obviously be the mains power in. So I'll couple some power up to that, and then we'll see what happens. Right, so we have some mains connected. Let's plug it in and hope it doesn't go bang. Right, so we have power on. And we have 248 volts going there. No power light, no nothing. So yeah, he's correct. It looks dead. Right, so I'm going to unplug it. And now we need to work out how it actually comes apart. Right, I'm going to start by removing the wall mounting bracket. Now I think I've got to flip it over by the look of things, because it only looks like there's a couple of screws on the front that hold this plate on, so looks like I'll have to remove all these screws around the edge, and then we'll have some access to the internals, hopefully. Right, so that looks like all the screws removed. That's the back panel off. It looks like we've got some nice big inductors or transformers here. I think they're inductors actually. And some nice big juicy capacitors there, so I think we might have to proceed with caution with this one. Right. Yeah, just saying the fan there actually looks quite clean. In fact, the whole unit actually looks quite clean inside. Right, I've just flipped the board over, and one thing I've noticed is that relay there, you can see it looks like a lot of black soot around it. I can't actually see anything obvious on the board that looks to be blown there. We've got a little memory card module there, it says 256K, some RS485 comms. This appears to be the inverter board. We've got 4 big capacitors and a load of MOSFETs or whatever by the look of things. This looks like the logic control, and the board there is the display and the user input switches. So I would think if there was any problems with this, especially to the related to it actually not coming on, I would think it's going to be on this board in any case, because this part here looks like a switch mode power supply. Well, I could be wrong. It could actually be. I'm just actually trying to see where it would be powered from. Yeah, actually, yeah, it probably would be, because then it would probably come through this ribbon cable here. I just couldn't see any power cables running from there to there, but it probably goes through that ribbon cable, which would make sense. So I think that could be the switch mode power supply for the logic, and all this is probably switching for the switch, you know, the solar panels, like disconnect them rather, or disconnecting the mains or whatever. Right, I'm gonna start taking this board off the metal casing, and we'll see if there's any problems on the back of this board. I've got a feeling there may be. Oh, right. Well, that doesn't look good for a start. Right then. I think we're starting to see the problem now. So, it looks like there's a failure on these relays, or the joints where the relays go to the circuit board from here and here. There and there. Right, I think we might take this back into the bench where we can actually work on it. Right, so I brought it in on the bench. We'll put some IPA around here, and we'll try giving it a bit of a clean up. So I think there's 4 relays when I've looked at the other side. So we've got, that's the relay energizing coil there, and obviously it switches between that, it links that contact to that point when it's energized, so that's one of the relays there. There's another relay here, that's the contacts for the energizing coil, and it switches obviously from there to there. And then if we come down here, that's the energizing coil, and it switches from there to there. And on this one, that's the energizing coil, and it switches from there to there. Now, we've obviously got some damage to the track here, and possibly the leg burned off. You can see where this starts. It just starts by a bad connection. It's basically a dry joint around the around where the legs soldered in, and that gradually gets worse and worse and worse until it starts arcing, and that's when you start getting things like this and eventually failure. So right, we'll see if we can extract these relays, and then we'll see what condition they're in. Right then, there's one relay removed. And there's the second relay removed. Third relay removed. And that's the fourth. Right, well, that's the 4 damaged relays removed, so we'll have to order some of those. Let's check the, I'll just clean up a little bit first round here, just to see if we can get any of this any cleaner. Right, so let's have a look at the other side of the board and see what that's like. Right, looks in a bit of a sorry state as well. So looks like we've got damage to this area around here. I think I'll clean it up with a bit of IP first, and then yeah, it's actually you can see round here where it's actually burnt away the copper as well on this side of the board. Let's clean these ones up slightly. Right. Right, so I shall see what parts availability is like, and then we'll continue with the video from there. So the new relays have arrived. So what I'm planning on doing is soldering the new relays in, and then to take some load off the burnt tracks, I'm going to try and use some thick copper wire here. This is some earth off some 2.5 cable, just to bridge it across. I'll solder that directly onto the leg of the relay, and then onto the point where it goes to. And hopefully, if I do the same on most of them, that should strengthen these pads up. So that's the plan. Right then. I've got a bigger solder iron heated up as well, which I'm going to use to do the larger contacts. So I'll just solder all the smaller ones in first, and then we'll use the bigger iron. Right, I've tried the board back in the rest of the inverter, and it still appears dead. I even tried putting some DC voltage onto the inputs of the solar panels to see if that brought it back into life, but that didn't work either. However, after I did that, I could hear a clicking, which sounded like a switch mode power supply that was trying to start up and then shutting down, and then trying to start up and then shut down. Now, this here looks like the switch mode power supply that controls or sends power to the logic board. So it'll probably be switched by that device there, I would think, which switches the transformer. It then goes through two rectifier diodes, because there must be two supplies, two separate ones. That's obviously one supply with the capacitor on, and that's another supply with the capacitor on. I don't know what the voltages are supposed to be or whatever, but what I have noticed, if I measure this diode, I seem to be getting a reading, and if I measure this one, we have a dead short. And one of the other things I noticed was it looks like the flux, like the factory flux on the actual component itself, looks to be sort of yellowed, which suggests that the component's obviously been getting hot and then it's failed. So I'm going to remove that, see if the short disappears, and then if it does, we'll order a new one. let's see if the short's still there. And the short is still there, so there's something else as well. Right, so I've had a quick look over the circuit board and I've checked a few components just around the end here, and there was a diode just across here. Now I've just removed that, and if I can get my probes on it, I'll try it the other way. So that diode short circuit. Now if I measure across here now, the short is gone. So what we'll do is we'll order a new diode for here and a new diode for there, and then once those come we'll continue with the video. Right, so the parts to fix the inverter have arrived now, so I'll just get one out. Just put a bit of flux on here first. Just get that in roughly in the right place. Like so. I'll get the other part out as well. Just make sure that we're putting it right there, round the right way. Tell you what, let's put a bit of flux on that one as well. I'm just going to use that iron to put these parts back on, because they're in quite close vicinity of that aluminium capacitor there. I don't really want it exploding everywhere, so right, I think that'll do for that one. Right, I think it's just a matter of putting it back in the unit and testing it again now. Right, so I've just popped the unit back together. I haven't put the back or the cover plate back on currently. Now what I've got an extension lead here with a power wire that comes into the unit for the main power. It just goes into here. So that's the main power coming into the unit there. To simulate the solar panel, what I've got a test meter rigged up to a part of an old power supply there. I'm just using the bridge rectifier and the capacitor on that circuit just to turn the AC that I'm going to produce with this old washing machine permanent magnet motor. It's off an LG direct drive. So what I'm going to do, I'm going to use me Milwaukee knocker gun here to spin that, which will then generate some AC voltage, which will then go through this board, get rectified to DC. It'll display it on this meter here and hopefully power the unit up. And then we'll see if we can produce any power, and we'll just double check that the unit actually works now. So I'll just quickly set the set this up on the tripod and we'll give it a go. Right, so I've got the test meter in shot, and you can be able to see the LCD and stuff on the display on the inverter. So, because apparently it doesn't actually do anything until it's actually got a power source coming from solar panels, or obviously I'm generating it with an LG washing machine, but that'll be the same thing. So I'm going to start spinning this with me gun and we'll see what happens. Here we go. And we're producing about 171 volts at the moment. If I go a bit faster, you'll see the voltage go up there. And it's going to try and connect to the mains any second there. Right, it seems to be taking a bit of load there now because it's a lot harder to spin it now with the gun, so we'll just wait until it actually starts telling me. There we go. We're generating 114 watts of power currently. Right, I've just stopped it there, so you can see the voltage slowly dropping down on the test meter there. And it's saying we're not producing any amps at the moment. And it's actually measuring the voltage of the input there, which is slowly going down due to the capacitors on the little board, plus the internal ones that are actually in the unit. So yeah, it appears to be working and generating. So I think that's another successful fix. I think the clock fail thing that just popped up there, that's because I've had the battery, the board out that's got the battery on that keeps the backup for the time on the unit. So just reprogramming the time and date should sort that out. So, well, yeah, it appears to be working fine there now. So I'd say another successful fix on that one. Right then, if you enjoy these type of videos, please give it the thumbs up. If you want to see more like it, then please subscribe. Any comments or questions, please leave them in the comment section below. And as always, have a great day. Thanks for watching.